get in time response. So apply inverse Laplace transform. So if we apply the inverse Laplace transform, again the same thing. I am not writing in details because I already wrote in details in here. So it is just like that. Ct is equal to k by s. K by s, 1 by s. What is that? 1 by s. Ut. So that is k into ut plus here k by t alpha minus t into s plus a, that is E inverse at. So E inverse t by t. So now this ut, what is that? Consider in its step function ut is equal to 1. Consider ut is equal to 1. So you will have Ct is equal to k plus k by t alpha minus t E inverse t by t. So here we have k by t alpha minus t inverse t by t. That's the response, output response. If there is a first order system having a 0. So now here you see, what do we have? We have this term. We did not have that before. We have an alpha term. This alpha is what? Alpha is 0. 0. So now we need to analyze how it will affect our system. There are two systems without 0. This means no zeros, only k, no zeros. Here we have a system with 0, that is 1 0. So k by 1 minus t inverse t by t. Get k by t, k inverse t minus alpha minus t inverse t by t. Now, if we are considering this t value is higher, t value is greater than alpha, like suppose I can write 2 minus 10. Alpha is 2, t is 10. So if t value is greater, so what will happen? You have a value of minus 8. So minus 8, that means there will be a value of minus n. N value can be anything. 1, 2, 3, 4, anything. So it depends on whatever the value it is. But there will be a minus. So we can define it as minus n. So we can simplify this term as minus n if t is greater than alpha. So we can rewrite this equation k into 1 minus n by t. Now we will see how this will affect our system. Look at this. We have a system, this is a system. In this system, what is alpha? 2, t 3. So this system you can rewrite it. How? Here k plus k by t into what? Alpha minus t E inverse t by t. Now here, what is this? Is alpha, this is t. So here alpha equal to 2, t equal to 3. So you will put the value k and t. Put the value k, 10 by 3, 2 minus whatever. Now this will give you a value of what? This is minus 1. So this will give 3 point something. So this is minus 3.33. That means 7.6. 6 point. 6.7. So this is just write it here. This is 6.7. So this 6.7, what is that? This is called here the system. This 6.7. The system will start from here. Your output response will start from this point, not from 0. Not from 0. It will start from here. This is called offset. If there is a 0 in your first order system, it will create an offset. This is an offset. The offset means the system will start from that point, not from 0. Not from the origin. Not from the origin. It will start from that point, whatever the value it is. It can be any value, it depends on k and alpha and t. So this system will start from the offset point. Now suppose here if we have another system, again here alpha, here there is t, so calculate it. 10. Now t is less than alpha, not greater than alpha. T value is less than alpha. T 1.5, which is smaller than alpha. Alpha is 2. So here you will have something like 3.33 again. This will give you 13.33. Here 13.33. This is also an offset. The system will start from this point. The system will start from that point. So if there is a value 0, there is a 0, the system will start from the offset point. Offset point, whether it will from the down or up. So 13.33, the system is started and it will go down. Now look at this. The system is like this. If there is a 0, if there is a 0, depends on the value of alpha and t. If the t is greater than alpha, then the system will start from here. If the t is smaller, the system will start from there. All the time, the system will reach to one steady state point. What is that? K. Here, what is the value of k? 10. The system will go to 10 all the time. The system will reach to 10. Because this is k. K equal to 10. Steady state gain. It is not 10 by 1, it is 10. Because we have it instead. We consider that as UT. UT is equal to 1. We consider that. So it is 10 by 1. So makes it 10. So all the time it will reach to one point, steady state point, which is k all the time. No matter whatever the value, smaller or greater, it will reach to the same steady state point. One point. So there are 3 graphs. 2 graphs are based on with 0 and different values of alpha and t. One, t is higher value, and another one, alpha is higher value. And the system without 0, look at this, the system without 0, it started from the origin, from here. From here. But the system with 0, it starts from the offset point. The system with 0, it starts from the offset point. These two having zeros. But here, no zeros. So it starts from the origin. So this is the difference. If there is a 0 in your first order system, the system behave like this. If there is no 0, the system will behave like this. But you see, all the time the system is reaching to this point, which is 10. All the time. Because the gain is same, gain value is same. K by t is plus 1, here k is 10. Here also k is 10. So all the time the system is reaching to 10. Okay, there is one example we will discuss. This is a thermometer example. Thermometer, you all know this, right? You all know this, right? What is this? Temperature, body temperature, measuring body temperature. If you are sick or if you have cold, you use this to measure the temperature. Now we will observe what is the error, how much error there is in this temperature measurement. The error ratio we will find it. So this thermometer, it is a first order system. This is a first order system. What is that? This is this. This is the first order system. This one, this thermometer measurement. So a thermometer requires 1 minute to indicate 98% of its final value. Look, it takes 1 minute. 1 minute is 60 seconds. 98% of its output, that is CD. CD. This is what T. It takes T to reach 98% CD. Now this is assuming this is a first order system. Now find the time constant. T is equal to what? First order system means this is a K by Ts plus 1. It is Ts plus 1. Now what is the input? Look at this. Step input, UT. It is a step input. Second, this is the first question. Second question, if the thermometer is placed in a bar, the temperature will increase linearly with 10 degrees Celsius per minute, which is 10 by 60 degrees Celsius per second, because this 1 minute is 60 seconds. So 10 by 60, this is degree Celsius per second. Now we need to find out the error E. What is an error? Input by out, input minus output. Or output minus input. So error, we will find it in this way. So now, first of all, you need to find out this T, time constant. Second, you need to find out ET, error. Okay, let's do it. Now we know that what is the input? Input is 1, UT. Step input, unit step input, RT is equal to, RT means not RAM. RT is for this input. This RT, it is RAM signal. It is not, this is step input. Because we are using RS here, that's why we are using RT here. But this is UT. So don't be confused with this. This is UT. This is UT. But we are using RS, that's why we are using RT here. Now RT equal to 1, so we can convert it in as to main. RS by 1 by S here. We have seen here 1 by S. UT is 1 by S. So now this equation will be like this. 1 by S into ST plus 1. We already know that. Here, 1 by S into ST plus 1. We are not considering 0 here. It is just without 0. This system is without 0. So what will happen? 1 by S plus T. So we will apply inverse Laplace. Apply the inverse Laplace. We will get 1 minus the inverse T by T. Here it is. We have some alpha term. But if there is no 0, we will get this, because this inverse Laplace of 1 by S, inverse Laplace of 1 by S, here it is UT. And what is the value of UT? UT is 1. 1. And 1 by S plus 1 by T. 1 by S plus A, this is E inverse AT. E inverse AT. So we have E inverse T by T. So this is your final equation. Now, what do you need to find? You need to find out this T, greater T. But this quantity is given. Look, It takes 1 minute to reach 98%. This is t, small t, and this is ct. So this value and this value is given, t and small ct. So here we have the equation. Look, we have t and ct. So you can find out t. Here t is 15.33. Calculate the equation and you will get it, that time constant. That is the time constant. That is the first part. Now, what do we need? The second question tells us that we need to find out the error. That is the final measurement. We need to find out the error. So how do we find the error? Here t is equal to 15.33. Here put the value over here in this equation. So here put the value and you will have, now we have the t value 15.33 here. So now again apply the Laplace, because we cannot keep it in time domain to analyze. We need to analyze it, so we must need to convert it in Laplace domain. So again we use the Laplace transform, and then we need to find out the error signal. What is the error signal? Error signal ET is equal to RT minus CT. What is this? RT, input minus output. So here apply the Laplace. If you do the Laplace, of this, then it will be ES is equal to RS minus CS. Now this CS is not only CS. Why? Because it is changing at a rate of 10 degrees per minute. So 10 degrees Celsius per minute, I already told you this is 10 degrees Celsius per second. So this one will be multiplied with 10 by 60 degrees Celsius per second. So this is 10 by 60. So this is 1 by 6, 1 by 6. So now you have the RS value, you have the CS value put down, because we are considering RS is 1 by S, 1 by S, 1 by S. So it is 1 by S unit step. And CS value, what is that? Here, this is the CS value. So do the calculation. You need to do the calculation. And finally, we have this equation. So, and again, apply inverse Laplace, we will get this. Now, this t value is not known. This t, what is that? This t value, it is actually the time constant. Look, our indication in the exam, in the question, tells us it reached to the output 98%. We already know that steady state value requires 5 time constant, 5 time constant, to reach 100%, 100%. But our question tells us that to reach 98%. So that is 40. So this t is equal to 40. And t we already know the time constant 15.33. So that is the t. That is your t. Because it depends on which output you need. 98%, 99%. If it is tells on 99%, then it is must need to multiply with 5t. But it is 98, so you must need to multiply with 40. So here put the value of t here, and then you will get your output, final output 0.84 degree. That is the error. That means while you measure the temperature of your body, you will get an error of 84 degree. That is, it will be higher or lower. That is called error ratio. Every thermometer you will see there is an error ratio. So here there is an error ratio, that is plus minus 0.84 degrees Celsius. This is called error. Every thermometer you will see this. every thermometer, while you check the manual, you will see like this, plus minus something, the arrow. That means it can be higher 0.84 or it can be lower 0.84 from your body temperature. That is the arrow. This is how we calculate the error from a system, by using the control system. Alright, now let's talk about some pole zero map and time response. Like here we have a system k by d s plus 1. Now there is 10 by s plus 1. So how can we draw the pole zero map? That is pole zero map. And how can we write down the step response? What is this? This is k. This is t. So what is the pole? Pole is equal to -1. So here there is a pole and time constant is 1 t, because here we have 1s. So that is a pole zero map and time constant step response. Second one, let's see here, 10 by s plus 2. So here 10 by s plus 2. What is pole? Pole is -2. And what is t? T. So our equation is t by t, k by ds plus 1. So you need to convert it. 10 by 2 half s plus 2. So this is 5 by 0.5 s plus 1. So t is 0.5. This is t. Second one. So and the pole is -2. -2 here. Third one. 10 by s plus 3. So the pole here, the pole is s equal to -3. -3, here's the pole. And we define the pole in this, it cross x. And how do you find t? 10 by s plus 3, 10 by 3, 1 by 3, s plus 3. So this is 3.33. This is 3.33 s plus 1. So this is t here, 0.33 s plus 1. So that's how you draw the pole zero map with time constant. Step response. How do you draw the step response? Step response means that we must need to find out the gain. So what is the gain here? K is equal to 1, right? Because here t is equal to 1. So we don't need to do anything. Here, what is the gain? We cannot directly write 1 because it is not. We must need to write it in this format, k by ts plus 1. If it is not, convert it. So how do you convert this? S plus 10. How do you convert it? Here, 1 by 10, s plus 10. Here also 1 by 10. So this is 0.1. This is 0.1 s plus 1. Now this is your k. 0.1. Look. K. This is your k. You cannot directly write. You must need to convert it in this format. This is the format. K by ts plus 1 all the time. So after that you can write down the gain. This is k. Here this is 1. This is called unity gain. Unity gain. Why? Why? Output by input is equal to 1 by 1, which is 1. Output 1, input 1. That is called unity gain. You see, that's why you got 1. But here it is not. Okay, it is not unity gain because the output is 0.1, input is 1. That is not unity gain. So here the gain is equal to 0.1 by 1. 0.1 by 1, what is that? 1 by 10. So that's how the step response will be. Because of that, here the gain will change, and because of that, this time constant will change. T will change. Here the T. What is the T? 0.1. 0.1. Here the T. What is the T? 1. Look, 63%. This is a 63. 63%. This is 63%. So this is T. That's how we draw the polynomial step response for different system. Okay, now we'll talk about a system that is having a delay. First order system having a delay. We just saw first order system with a 0. Now we will talk about if there is a system that is having a delay. What is the delay? If you see this type E inverse STD, E inverse STD, this TD is called delay time. If you see a system like that, suppose if I just write one like 5 by s plus 2, 5 by s plus 2, E inverse 2s. Here, in this example, this is TD, delay time. So how does it will affect your system in your first order system? How does it will affect? Look, the system, if you have a delay, it will not start from here. It will start, but it will continue like this. So it will make a delay till TD time. Here, it will make a delay till TD time. Here, now it will start to rise. From here, it will start to rise. From this point, it will start to rise. But before it was not rising. It was not rising, it was having a curve. Why curve? Because of this E inverse, that is make a curve. I already told you that before. E inverse having a curve, so it will make a curve. But it will not start to rise. Now, while it reaches to this TD point, now it will start to increase. So the system will lag. The system will having a delay now. Look at this. System will be slow. System will be slow. Why? Because of this delay time. Now, how much it will slow? Look. Suppose here we have a system. Now we have this TD. And now we know the first time constant T, greater T, that is T, 3. T equal to 3 and TD is 2. TD is 2, we already know. The system started from here. And now the time reached to first time constant is 63%. 63%, which will give you T equal to 3. Now here, look at this. The time differences. Total time is 5 seconds. 5 seconds. Before it was 3. So if there is no delay, then the system would be like this. No delay. And the time would be like this. T equal to 3. Now there is a delay time t equal to 2. The system does not start from the 0. From here, it will have a delay, and from the t equal to 2, it will start to rise. It will start to respond, and after 3 seconds, it will reach to 63%. So the system will have a delay of 5 seconds. So here there is 2 seconds. So the system will reach to 63% in 5 seconds. 5 seconds. So the delay is 2 seconds, and the time required for the 63%, first time constant 3 seconds, total is 5 seconds. That is what happens if there is a delay time. The system will be slow. The system will respond slowly. So these are different explanations and analysis for different type of system. Like if we don't have 0, if we have 0, and if there is a 0, how does the system will behave? Depends on alpha and t. And then we have seen that if there is a delay time is given in our system, there is a delay time in our system, how the system will behave. There will be slow, the system will be slow for how long? So these are the explanations of the analysis of the first order system. So now let's talk about some first order system example. I will give you 2 examples. One example is based on electrical system. So first example is based on electrical system. What is electrical system? Circuit. RC circuit. A common example, RC circuit. So RC circuit are having one R, one C. What is R and C? R resistor and C capacitor. Now, if we apply AC voltage here, AC input, if we apply AC input here, you know the AC and DC. There is 2 input, AC and DC. AC you define it by like this because there is frequency, and DC like this. Now, if we apply an AC input, there will be some impedance. What is an impedance? Impedance is the opposition of the current flow. Impedance is the opposition of the current flow. Current flow. Like the resistance. Resistance is the opposition of the current flow. For DC, impedance is the opposition of the current flow for AC. Here. So this impedance, we can define it by R plus Jx. Impedance, we can define it by R plus Jx. This is R. This is Jx. Now, what is X? X we call reactance. X reactance. What is the reactance? Reactance is also opposition of the current flow due to inductor and capacitor. Inductor is L. Inductor is L. L is the inductor. And capacitor, you know that. So X is XL to XC. We can write like this. X is the differences of XL and XC. So here, if there is no XL, then it will be just XC. But here, in this circuit, there is no L. L, what is L? L is look like this. L is look like this. This is L. Inductor L. And capacitor is look like this. Resistor is like this. So here in this circuit we don't have. So XC will XC. So here this one, it will be R plus JXC. Now if we consider the impedance for R, then we will write it ZR. ZR is equal to R for the resistor. If we consider impedance for C, GC is equal to, so we don't have R here in this branch, so only C, that will make you JXC. Now if we want to analyze this, it is in time domain. If we want to analyze this, we must need to convert it in S domain. So we will use a voltage divider. But so this one, if we convert this in S domain, it will give RS. And if we convert this in S domain, so it will be 1 by SC. So now here, this is in Laplace transform. This is the Laplace transform. So we can write E out by EI as equal to, here we need to apply the voltage divider rule. Voltage divider rule. Voltage divider, what is that? V out is equal to R2 by R1 plus R2 into VI. This is the voltage divider rule. So here you apply that. This is R2. This is for DC. This is for DC. That's why it is R. So we apply this. R2 is C. So ZC divided by ZR plus ZC into EI. We don't need to write it because we just took it in this side. So here this one, E out by ES is here by ES is here 1 by SC R plus 1 by SC SC RSC plus 1. So that is 1 by RSC plus 1. That's how we get this. This is the gain or get the transfer function. This is the transfer function. So for this RC circuit, transfer function. Or gain. You can call it a gain as well. So that's the analysis for the first order system. This is first order system. You see here. This one. It look like K by TS plus 1. This is T. This is T. K. This is K. K equal to 1, T equal to RC. That's what, how this is a first order system. Second one, mechanical system. Speed. How to measure the speed? If there is a speed, apply a speed, input, initial speed, and then how can you find out the gain? How can you find out the transfer function? Look, there is a mass of this car, mass M. So if there is a mass and if we apply a force, there is a Newton's law, F equal to ma. We know the Newton's second law, F equal to ma. So what is this A? A is dv by dt. Rate of change of velocity is called acceleration. So this one we can write it as v dot So we will directly write it. Now, what is f? F is the initial speed, initial velocity, which is u, minus the opposed velocity. So that is v, frictional velocity, frictional constant. So because of the plane, there is a frictional velocity. So we can write it u minus v is equal to m into v dot. Now this is in time domain. We must need to convert it in s domain to find out the transfer function or gain. So how do you apply the Laplace transform? Apply Laplace. U will be us minus v into v will be vs is equal to m into v dot. Time domain v dot, that is v by dt. So we already know that if there is a derivatives, then s will be multiplied s. So s into vs. So here we have vs in vs. So we take common of this vs into ms plus b is equal to us. So you can write it here. Vs to us is equal to 1 by ms plus b. Now that's your transfer function or gain. So what is t and k? How do you find t and k? K by ts plus 1. So make it how? You need to divide it 1 by b. ms plus b into also in the numerator 1 by b. So here is m by b is plus 1 by b. This is your k, this is your t. First order system. So that's how you will find out for the mechanical system, first order system, you will find out this field. That's all about today's lecture. In our next lecture, we will talk about second order system. What is the second order system? I will upload the PPT in the group. Read it before to come to the class. Second order system, in our next class we will talk about this, not this.